Welcome back to the channel. Nice to have you guys, and today we'll take a brief look at regular expressions in general and also how it's implemented in the Rust programming language. Now this course is intended as an introduction to Regex, so you don't need to have any prior knowledge, and you don't even have to program in Rust. It's also useful because Regex can really be used in any language or most of programming languages today. So before we start, I have to make sure that I put forward this disclaimer because Rust Foundation has issued some new policies regarding the protection of their trademarks, and they've really manifested a rather oppressive approach to that. But that's not a topic, so just to make sure, it's all legal. I'm not in any way affiliated with the Rust Foundation, and the following material is for educational purposes only. So, what is Regex? Regex is a tool for creating patterns for matching, locating, and managing text. It originated in 1951 by mathematician Kleene, and as you can see, this is a rather old concept. So this predates the Unix era, this predates the C programming language, and in terms of technology is really old, this concept, but it's very much alive, and it's really omnipresent. As a programmer, I'm sure you have heard of it, maybe you have even implemented some of it, and yeah, it's really useful. And there is nothing in terms of string manipulation that really comes close to Regex. And it can be used in nearly any language, so this is very important. What you learn here is not specific to Rust, so Regex in itself is something independent and can be used in any language. Now each language has its own implementation, but these implementations are very similar. And as I've said, it's very powerful and much more advanced than normal text search. So, normal text search, I guess you know it. You're on a website, you can then press Ctrl F for find, then this text box over here will appear, then you can type in the search term what you're looking for, and then the browser will show you all the results. And this is pretty useful, and I guess all of us are using it, but it's also pretty limited. Now this, for example, is a regex, a regular expression, and as you can see with this pattern over here, we are matching any phone number, and I guess you've noticed that these phone numbers are even formatted differently. So this phone number over here doesn't have any delimiter, this has hyphens, this has spaces, this starts with these parentheses, you know, and it matches all of them. So here you can see the power of Regex. And don't worry too much, we will go step by step, and in the end of this course I guess you will understand what this means. And I know it looks very cryptic, but it's actually pretty easy. Once you get the logic behind it, you will see that it's not nearly as difficult as it seems in the beginning. So regex in Rust. Now regex is not implemented in the standard library. For example, in JavaScript you can use regex without importing anything, but in Rust this is external, so you have to import the crate, which is called regex. I will show you that. And this syntax is similar to Perl style regex, so if you're coming from a Perl background or you have programmed in Perl, then this will be very familiar to you. it has full Unicode support, and some of the features like look around and back references are not supported yet, but I'm sure this will come in the future. Now let's start with the basics. So this is a simple regular expression. As you can see, we have here the symbol for start of line. This $ is the symbol for end of the line. So we match this pattern that should be after the start of the line and before the end of the line. Then in these brackets we match some characters, and in these curly brackets we define how long this sequence of characters should be. Now again, we will go step by step. This is just a little start. So let's see. I will now switch also a little bit. So as you can see, we have here the period, and the period matches any single character except a line break. So let me switch over here. There is a really fantastic website called Regex R, and here you can test out the regex patterns. So let's see. The period matches any single character. So if I type here a period, as you can see, we match every single character. Period just stands for, this could be anything. It could be a character, it matches spaces, it matches symbols, it matches the period itself. It's also a letter. And yeah, that's basically the global character. It matches anything. Then we have character class. So this matches any character contained between the square brackets. So for example, I have here a character class. Now this is empty, so it doesn't match anything. Let's now see, I want to match uppercase letters. So for this, I can type A to Z in uppercase, and as you can see, we only match uppercase letters like that. As you can see, this is uppercase, uppercase. Here are 4 uppercase letters in sequence. And this is negated character class. So matches any character that is not contained between the square brackets. So for example, over here we match A to Z letters that are capital. Now we can also type it like that, so it matches capital letters and small letters or lowercase letters. And as you can see, it matches anything, any letter, except for example this symbol, these periods, the spaces are not matched. Now I can reverse that by adding, and just to make sure, this has to be inside the brackets. So as you can see, this is the syntax, it has to be inside of the bracket. Now as you can see, we inverted that. If we add this, it gets inverted. So that means match anything that is not uppercase A to Z or lowercase a to Z. As you can see, now we match the spaces, the symbols, the periods, anything that is not a letter. Then we have the star, matches 0 or more repetitions of the preceding symbol. So let's say we want to match uppercase letters and only uppercase, A to Z, like that. but we want to match 0 or more. So we can do space. And as you can see, it didn't change anything because this is still valid. This is one letter over here. We are matching more. But what did change, as you can see, maybe I'd zoom in a little bit so you can see it better. If we do it like that, these matches are single characters. So this matches P, C, R, E. If we put the star over here, now as you can see, it matches this whole word. These are not matched as single characters, but as a whole word. So we match 0 or more of this sequence. As you can see, match, and the range is from 129 to 132. So this matches this range and not a single character. If I remove that, as you can see, we match just single characters. Now the plus is actually very similar to the star, but the plus matches 1 or more repetitions of the preceding symbol. So this matches 0 or more, and this matches 1 or more. So again, this will be the same thing. As you can see, we match 1 or more. Then the question mark makes the preceding symbol optional. So for example, we want to match regex R. Now you can do a real match. So if I type regex R, then it matches this word exactly. Now let's say I want to make this letter optional. So then regex will also be matched. I put a question mark over here, and as you can see, this makes the R optional. So in the pattern, it could be matched, so we have this, but also it could not be matched. As you can see, regex is also a match. Then we have braces, matches at least n, but not more than m repetitions of the preceding symbol. So for example, I want to match a bird, A to Z, A to Z, and actually there is a simpler way of writing that, but I will show you that in a moment. So we want to match this sequence, but instead of doing it like that, I want to specify that the word should be at least, let's say, 8 characters long, and at most 15. Like that. Like that. Let's do 8. As you can see now, it gives me only words that are at least 8 characters long, but at most 15, as you can see. And this is a character group, or it's also called capture group. So these matches the characters X, Y, Z in that exact order. So for example, I want to match regex XR or regex, like that. Now as you can see, we have a group, so it matches either that or that, as you can see. And these groups are especially useful because you can then also access these groups and manipulate these groups, and I will show you how that works. Yeah. And maybe just very quickly, the characters X, Y, Z in that exact order. So it matches it in that exact order, and not like that what we did over here. If I type regex like that, it would match any word that has R or an E or a G or an E or an X in it. So that's the difference between the two. As you can see here, G matches because in here is a G. So this is just a character class. We match any character inside of here. But in a group, it has to be in that order, like that. Was, it will match this word. If I type like that, as you can see, was, but also notice that it matches every single character on not the whole word. And here we have an A because this is inside the character class. Here we have an S because again it's inside, and I hope you get the idea. So here we have alternation, matches either the characters before or the characters after the symbol. So we can alternate. For example, I want to match S, or I want to match, or let's do R or E. And as you can see now, we match capital letter R or capital letter E. So these get matched in the text. And escaping, this allows you to match reserved characters. And as you can see, we have used that and this and that. You basically now know all these characters. Now, what if you want to match, for example, a period? I want to match, for example, this period over here. Now, if I type period, as you know, it matches anything because the period is the global operator. Now, to escape that, we use backslash. And as you can see now, it takes the period as a literal character and it matches it. So this is called escaping. Now, beginning of line. So what if I want to match regex like that, but only at the beginning of the line? Now you can see it matches that and that, but this is not at the beginning of the line. So if I add this, as you can see now, it's only matching words at the beginning of the line. The same thing for the dollar sign. This matches the end of the line. So any pattern that is exactly before the end of the line. All right. Now, there are also some flags I want to show you. So we have global, and this matches anything. So if I would remove that global and I would type regex, it only matches the first match. But if we do global like that, and as you can see, it matches anything in the text. Now, case insensitivity. So if I do like that, regex, it matches it because I have here the I flag. Ignore case. Multiline. This is, for example, if you have I remove multiline just to show you. I want to match at the beginning of the line an uppercase letter. As you can see, it matches only the first line because this character for beginning matches only the first one. If you do multi-line, as you can see now, it matches all of the lines at Same thing with end, with the end of line character. Let's see, single line, Unicode, this is for Unicode characters, and sticky, I don't know what that is. So maybe some resources. So Regex R, I have shown you that. Then there is a really good GitHub page called Learn Regex the Easy Way. So that's actually how I learned Regex some years ago. Learn Regex GitHub. Yeah, that's this one. As you can see, Learn Regex, and it's even available in many different languages, and it really teaches the basics. And yeah, it's not even that long to read. I guess you will need 10 minutes to go through, and it's really explained very well. So I really suggest you take a look at that. And then, for example, for Rust specific use cases, you go to the Rust documentations, and FreeCodeCamp is always a good resource for things related to programming. All right, we are done with the presentation. So let's see. Then we can now start with actually going into the implementation of Regex inside Rust. So I've already made a cargo project like that. It's called Regex. Like that. And it's simple project over here. I have added over here, as you can see, dependencies. I have the Regex crate and also lazy static. I will explain in a moment what's this all about. Now let's set IO. Here I can search for Regex. And as you can see over here, you can take this line and add it to your dependencies. Then don't forget to run cargo run, just so it builds, it adds the necessary dependencies to your project. So let's go to source, and I will open main.rs. Now we have a single function, main, and then we can actually write our first regex inside Rust. So first thing, we have to import regex. This is from the regex module, and this struct is called regex, like that. And I would say let's just write our first regex. So maybe just to show you what we try to do over here, we try to match the date like that. Now, how would you match that? So in Rust, I will show you that. In Rust, you could actually, you could do it like that, 0 to 9. As you can see now, it matches every single digit. So we can then say 1 or more. As you can see, it matches these 4, these 2, and these 2 digits. But we also have to match these hyphens. So we can add this hyphen here, and we can then add another of this block, one or more, again like that, one or more. What we have done here, we said we want to match digits from 0 to 9, one or more, in this case it's 4, then a hyphen, then another digit, one or more, in this case 2, another hyphen, and again a 0 to 9. Now for this there is a special symbol, it's \d for digit. So we want to match digit, and as you can see it matches. So let me remove that. We can then do the same over here, digit plus. So it's the same thing, really matches any digit character 0 to 9. Now we want to match exact dates. So even if I do it like that, as you can see, this would match too, but it's not a valid date. So what we have to do, we have to specify how long this would be. So in this case, the first one should be 4 digits long, because the year is written like that and it's 4 digits. The second one should be 2, and the third one should be 2, like that. Now if I would add 5 at the end, as you can see it doesn't match it, because we have specified that the last part over here is 2 digits long. Right, now we can also do, to make sure, beginning of line and end of line. That's what we want, like that, because we are starting here at the beginning and this is the end of the line. As you can see, if there is something else, it won't match, because we have specified that at the end of the line there should be 2 digits. All right. Now, how would we implement this in Rust? So we can write a regex like that. I will call the variable re for regular expression, and I will put regex new, and then we can write inside of here our regex like we would have written over there. Now in Rust there is something called raw string, and the raw string basically escapes backslash characters automatically. So this is a raw string, and that means match a digit. And this would be the same as we would write as a normal string like that. We have to escape this character. Right, but if you're using raw strings, you don't have to do that. You can directly match it, or you can directly write it without escaping. Okay, like that. And inside here we can then write our regex. Now we want, let me actually, I will write the date over here, just so we see what we match, like that. So we match at the beginning of the line 4 digits, then a hyphen, then 2 digits, then another 2 digits. Oops, 2 digits, like that. And then this should be the end of the line. Now, maybe just to show you, this new method on the regex struct will return a result. So what we'll have to do is to unwrap this, so we can use the inner value. All right, and then what we can do is just, I'll put it out so it will be clear. Like that. We take the regex, this variable, we type isMatch, and isMatch show you, isMatch returns a bool. So if a pattern matches for this text or for this string, then it returns true, otherwise it returns false. So as an argument, we give this string over here, and in this case we should have a match, so the output should be true. So let's see, 101, and as you can see, we get back true because this pattern matches this text. Now let's add over here a 5, then let's do it again. As you can see, now it doesn't match, as we've shown over here. If I add 5 over here, it doesn't match. Right. Then maybe something, you have seen that I've imported a crate called lazy static. So we can import that like this. And what this does is, if we would have here a lot of strings that are using the same regex, so this regex gets used many times, this would be really expensive because this regex on each call or on each usage of this variable will get recompiled, and this is rather expensive. So what we can do actually is we can use a helper function like that. We accept the string slice and return bool like that. This is just a helper function, and inside that we can use the lazy static macro like that. Then we can put our regex inside this macro, and then we can call from outside the function this this helper function. Now this just makes sure that this regex gets compiled once, and on every call it won't get recompiled. It just uses the static regex that is saved in memory. Okay, don't worry too much about that. I just wanted to mention it because in the future maybe you're using regex a lot more often, and this is just in case you use a regex a lot of times in the same program, the same regex, then you can consider something like that. Okay. Now let's get to another example. So let's say, let me delete that. Let's say we have, let's say we have over here a sequence of dates like that. So we have here a date, we have here another date, and the last date is here. Now, how do we match that? Again, we can use here captured groups. So as you've shown in the presentation, capture groups are inside parentheses. So this would be a group, this would be another group, and this would be the third group. Now we can, for example, match the year as we've done before. This would be a group, and this group represents the years in all of the dates, as you can see. Now here we will have the month. So this would be, excuse me, I have to add here hyphens with matches. As you can see, now we are matching also the month. And the last one would be the day, like that. Right. And as you can see, this comma and space and this and the spaces are not matched. So we are only matching the year, the month, and the day, like that. And as you can see, these are now structured in groups. So this is the first group, the second group, and the third group. What's that? The year, this is the month, and this is the day. Okay. Now, inside of Rust, we remove this. Inside of Rust, I can make a regex, like we did before, regex new. And don't forget this R for raw string. And we can just do the same thing as I've just did. We match the year, then the month, and then we match the day, like that. Don't forget to unwrap, like that. And then let me actually copy that so I don't have to type it once more. Let dates equal. Okay, so this is the text we want to match, or we want to apply this regex upon it. All right. Now what we can do is we can iterate over a method called captures iter. We pass it dates. So let me explain. This method over here returns an iterator over all the non-overlapping capture groups matched in text. All right, so we actually here iterate over the group. So we iterate over that, and over that, and over that. So in total we iterate 3 times, because there are 3 groups. One for the year, one for the month, and one for the day. All right. Now what can we do? I will do a print line over here. Let's say month and day and year. Now I hope you notice something. Over here in the original string, the year is first, and then the month, and then the day. But now over here we will print the month first, then the day, and the last one will be the year. And how we will do that? We can now access these various groups from cap. So use cap, and in this case the month will be in capture group 2. So this will be in capture group 2. So let's see, like that, in capture group 3 and capture group 1. Let me first make sure that this actually compiles, and then I will explain what we did over here. So let me do a cargo run, and as you can see, it's actually working. So we have from this input over here, let's take the first one, 2012, 3 is the month, and 14. We have the month first, which is 3. Then we have the day, 14, and we have the year 2012. All right? Like that. So what we did over here is we have iterated over these captured groups, and then we can access them using the normal syntax for accessing array or vector indexes. So in this case, the month would be the second one, the day would be the third one, or let me show it over here. The month is the second one, the day is the third one, and the year would be the first group. As you can see, we have first the second index, then the third, and then one. Now you would ask, aren't arrays and vectors normally 0 index, so they start at index 0? And that's true. Why isn't it like that over here? In fact, we can use get 0. What will be inside that? It will be the whole match. So we whole match like that. As you can see now, the last print statement will be the whole match, or the 0 index of this cap variable. Let me open the terminal. Again, I will run the program. And as you can see now, whole match will be this over here. This is the match. This is the actual match. Or as you can see over here, this would be that. This is the whole match. And these are just the various groups we can access. All right. Now, what we can also do is we can name these groups. So for example, I can do that. This looks a little bit weird, but we'll get used to it. So you have to use the syntax question mark a capital P, and then you can name this group. So I will put Y for year. Over here I will put M for month, and over there I will put D for day, like that. And we can then actually do something using the replace function. So we can do, for example, that after we take this regex over here and replace all. So replaces all non-overlapping matches in text with the replacement provided. So we can then provide this date, and then we can use over here these names. So we want, for example, the month first, and then we want the day, and then we want the year, and they are separated using slashes, like that. Print that out. Let me run it. Like that. As you can see, let's take the first one. And as you can see, we take the month first, then the day, and then the year. And notice also here they're separated using hyphens. Over here they're separated using slashes. So as you can see, we have accessed these groups using the names So for example, here we have month M, and we can use it like a normal variable, but you have to precede it with a dollar sign, like that. Right, now also in Rust there are some special flags. As you might notice, this looks a little bit, how should I say? I wouldn't say chaotic, but a little bit unstructured and unorganized. So what we can actually do is we can pass a flag. You pass flags. For example, here in the JavaScript implementation, you pass it at the end of the regex. In Rust, you place it before the regex pattern. So flags are passed like that. Inside parentheses, place question mark and X. X, I will show you what the X flags or the X flag does. The X flag will ignore white spaces. So what that means is we can now do it something like that. Actually, use the wooden key bindings over here just to be a little bit faster. Like that. As you can see now, these white spaces over here get ignored, but we have every pattern on its own line. And what's really nice about that, we can even add comments or comments. Here, month and day. Like that. Now, as you can see, it's a lot more organized than it was before, because we have each group on its own line, and we even have a comment explaining what this should match in this text or this string literal. And let me actually see if this compiles. Yeah, as you can see, same thing. The output is exactly the same, but it's just more readable like that. Now, let's say you have a text and you want to match it against many different regexes, and for this case we have regex set. And let me actually do it like that. So we can declare a set like that, regex set new. It's actually very similar to normal regex, but instead of passing a raw string directly, we pass it a slice. Oops, we pass it a slice of raw strings. So we can pass it like that, a word, or we can pass it digits, or we can pass it a Unicode letters. We can pass a literal search term like that. And in the end, don't forget to unwrap, because also this will return a result. Right. Okay, and then we can define, for example, a text, let's say football. Then make matches. We can then access this regex set, this variable set, matches, and this will returns the set of regular expressions that match in the given text. So, for example, we pass it text, that's this variable over here, as an argument into iter, and then we can collect. This will get collected inside a vector. Now then, again, print line, you can print it out. Don't forget to use a debug notation here, because vectors don't implement the display trait. We'll just pass it like that. Alright, let me see if it's compiling, and then I will explain. Alright, this will be the output. Now this looks a little bit strange, but you will get in a minute why this is looking like that. So let me actually copy that. So this will be the output. Like that. So what does this mean? So as you can see in this regex set, we have various different patterns. So instead of one single pattern like we did before, like that, regex new, and then we pass it like that. This would be one single regex pattern, but in here we have a set of different patterns. Okay, and what this does is we take this set and we match every single pattern on the provided argument, which in this case was foobar, the string, and then we collect that into an iterator and collect it in the end to a vector. Okay, so the output will be a vector. That's what we got over here. Now this output will just put inside the indexes which matched the given the patterns that matched the text. So for example, this means a word character. So let me show you that. This is word, matches any word character. This is actually also an abbreviation of this. So A to Z, 0 to 9, and underscore. This is exactly the same as you would write there. Okay? And this means match digits. And as you can see, digits are not matched. So this is 0 index matched, but there is no 1 because inside this text is no single digit. So if we see that over here, let's see. Now we want to match digits. As you can see, we don't have a match because there are no digits inside of it. This means Unicode letter. So I guess in JavaScript it's different, but let me see. Yeah, as you can see, this is a Rust thing. This matches Unicode letters. This matches 2, because over here we have Unicode letters. Then a literal search term like foo matches because foo is inside foobar. Exactly like if I would type here foo, it matches foo. Same thing for bar, and of course bar foo won't match. This won't match. Okay, but foobar of course matches because it's identical. So with this method you can test a text if it matches many various different regexes or regex patterns like that. Right. Now, as I've said, there are some special symbols. For example, as I've said, word matches any word character, which means alphanumeric and underscore. E matches any digit. Over here we don't have one. Let me add one. As you can see, this matches the digits. If I would do it uppercase, it matches anything that is not a digit. And the same thing for word. Now it matches any character. If I do it like that, it matches anything that is not a letter, as you can see. Yeah. Okay. And yeah, we've actually covered a lot. So maybe let me see. I want to show you some concept which is called greedy and ungreedy. This is also important. So if we have, for example, this text, get set on the mat, like that. Now we match capture group. We match any character 0 or more times, which follows AT, letters AT. As you can see, this matches the whole line except the period. Why? Because, as you can see, over here we match any character that is followed by 0 or more and then ends with AT. So you would ask why this word is matched. Simply because it matches the pattern. So we have over here this period with a star. That means that this get matched over here. Because as you remember, period can mean anything, any character. So this matches this, even the space. Because spaces are also matched with the period symbol. And this is what we call greedy. So this is greedy. It takes as much as it can. Again here, this matches because we have here space or white space and then a character and AT. That's exactly matching this pattern. So if you don't want to have greedy search, you can add this over here. And as you can see now, matches not the whole line. See here, it matches the whole line. This is a whole line. If I put here a question mark, it now matches this, then it matches this, then it matches this and this, as you can see. So this is what we call ungreedy. So it still matches that until AT. Then the match is done and another match starts here, as you can see. Then another match here and another match here. Okay. And what you also can do, instead of using that, for example, T, you can also use this. And I guess this is in Rust, because over here it doesn't match anything, but in Rust you can actually do it like that and put a pattern like that. and this means matches only at the beginning of the text. So it's very similar to that, but the difference is that even if multi-line mode is enabled, so if you have multi-line enabled, it will only match at the real beginning of the word. So let me actually show you that. Okay, so in here it's not implemented like that, but if I match, for example, uppercase letters at the beginning of the line, as you can see now, it matches only that. But if we enable multi-line, it matches uppercase letters at the beginning of each line. I hope you understand that. So if I put A, and again, this is not implemented in JavaScript, but it is in Rust, then it again matches only this one. And the same thing would be for example, we would want to match a point at the end of the line like that. So you can see now every dot at the end of the line is matched. And in Rust, if you only want to match the first line, you can use this. But again, it's not implemented over here. And maybe something else in Rust. The flags can be toggled, put on or off inside the pattern itself. So let me actually write a regex over here. Regex new, and we have over here a flag I, and this flag means case insensitive. So let me actually, these are the various flags. Like that. These are the various flags. So case insensitive, multi-line mode, allow point to match, new line character. I think this is also only used in Rust. So what this allows, if you put a dot character or the global character, it matches anything, any single character except the new line character. And if you put this flag, it will also match the new line. Then swap the meaning of X and X. So this swaps the meaning of greedy search and ungreedy. Unicode support, this is actually enabled by default, and X we have seen will ignore white space and allow line comments. So we will enable over here case insensitivity, then we match A one or more times, and then what we can actually do is we deactivate this flag. So here we activated it, and with this you can deactivate it. So you add a minus and the name of the flag like that. And then we match B one or more times. We can unwrap that. Let's see. Let's A, B, 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 and B. Should that. Okay, let me first see if that compiles actually, then I will show you. Alright, now this compiles. Let me actually do it like that. Right. Now we have an input of this string over here, and as you can see, we match over here case insensitive A one or more times. So this get matched, this get matched, this get matched, this get matched, and this get matched. Okay, and then we match case sensitive. So we deactivate the case insensitivity. Okay, we match B one or more times. So this will get matched, this will get matched, but this over here won't get matched. As you can see, this won't get matched because it's case insensitive. So this won't get matched. So the output will be this over here, and then these two B's. All right. And yeah, that's really useful that you can activate flags and even deactivate it in the same pattern. Okay. Right. And there are also some ASCII character classes. So, or I will show you just the most used one actually, because so actually or let me let me write a regex. For example, with the ASCII character classes, I can match ASCII characters. This is done like that. So now I want to do is match text, and I will compile it. As you can see, this matches because these are all ASCII characters. Now I can do alphanumeric. This matches 2. As you can see, true, this matches. And alphanumeric characters are these. This would be the same as you would write like that. This is called alphanumeric. And you can also do lower, for example. So let's see. This matches because it has lowercase letters. Now let's see digit. And this actually shouldn't match. So let's see. As you can see, this doesn't match. Why? Because in here we don't have any digits. So you can actually find that over here, the Rust documentation. As you can see, here you will have all the ASCII character classes. I don't use it a lot, to be honest. It looks rather weird to me, and it's just a lot more text, you know. You can write that pretty easy, for example, with this pattern, or with the patterns we have seen, like for example D for digit. So this is much more concise. Okay, now what I want to also briefly touch upon is the various methods in the regex struct. So we've seen the regex struct, and this provides a lot of methods. I will go only through the most used ones. So for example, find is really useful. So let me actually first match this so you can see what we are doing. Let's say we have this. And now we want to match that. So then we can use that digit 3, digit from 0 to 9, 3 again, and 0 to 9, 4. That's how it's written in the documentation. You can also use the D. And as you can see, we are matching this phone number. Now I can copy that and let me write this regex over here. Like that. Okay. And we'll do phone number. And notice this is a string, huh? Okay, so we can then use find. The find method lets us then for example, phone let's see, a variable result. In here, I'll use this regex over here. Find, as you can see, returns the start and end byte range of the leftmost first match in the text. So we can then provide phone number as argument. Okay, then we can use result start and result end. And I have to add over here. So like that. Let me see how that looks like. Like that. As you can see, we have this regex pattern I've shown you. We have this argument, this is the string, we match this regex pattern upon, and then we find the start and the end of where this pattern matches. So it gives us 7, and if we count 0, 1, 2, 3, 4, 5, 6, 7, starts at index 7 and it will end at index 19. As you can see, the find method returns actually a tuple, I guess. This will return a tuple. Okay, I think match, yeah, this is a struct of the regex crate, but in the end you can call upon this start, and it will give you the start index, and end, and it will give you the end index. Now we have also a very useful method which is called captures. So let's see, I will show you first the pattern and the text. So we have this type, not my favorite, maybe citizen Kane, and the year and the period, like that. Now we want to match this over here without the dot. How would we do that? Let's see. We first match this apostrophe. So you can see these two get matched. Then we want to match, and this will be our first group. We want to match anything that is not an apostrophe, like that, and one or more times. As you can see, now these are two matches. So we match over here the apostrophe and then anything that follows that is not an apostrophe. So as you can see, we match this here, and this over here is another match because the match or the pattern for that match ends over here because it's an apostrophe. Then we do it like that. So now this matches exactly this because we start with an apostrophe, this gets matched, we end with an apostrophe, and inside is anything that is not an apostrophe one or more times, right? Then we have a space, and space is this space, or I think you can even, you can even do a literal space, but it's better to use it like that to avoid confusions. And just to be sure, we match it one or more times too. That. And then, and this will be our second, no, sorry. First of all, we match the literal parenthesis over here. As you can see, this is why I have escaped it. So we match this literal parentheses, and then inside will be our second group. This will be a digit, 4 digits to say, and this will get closed by another parenthesis, as you can see. That's why we have escaped it. This is not part of the group. This is the actual parenthesis, and this too. That's why we've escaped it. So as you can see, we have two groups. This will be the first group over here, and this will be the second group. As you can see, even here, you have group 1, Citizen Kane, and group 2 will be the year 1942. Okay? And let me just put that over here. So that. Then we have the text, which will be this one. Okay, now what we then can do is the captures. We can call the captures method, and we provide, let's actually change that, text like that. Right. Then we can, for example, get the first capture group. So we can do caps get number 1 and s string. Like that. Let me see if this compiles. right, as you can see, as I've said, the first capture group, as you can see here, group 1 is Citizen Kane. This is the first match. That's the capture group over here, as you can see. And we have then, from this text, called upon the method captures, and this then returns the output or the text which matches the pattern for that group. So in this case it matches that. Okay, this is the first group. The second group will be this one. This is the 4 digits over here. You can see it even better here. As you can see, the screen parentheses show us that these are 2 groups. And then we can just access it using this syntax. As you can see, we get the first one. As you remember, if we do 0, it matches actually matches the whole match. As you can see, this would be the whole match over here. As you can see, the whole match, but we just want the first group or the first capture group. All right, and instead of using that, you can also do it like that. Caps 1. This would be the same result. As you can see, this 1. Let's access 2. As you can see, this is the second capture group. This is what we use the method captures for. Right. And we can even do in here, for example, we can do the named captures. Like here, for example, we name this title, and over here we name this year. Okay, and then over here we can access it using the name. For example, title. Let's do it like that actually. Title and year. Caps like that. As you can see, title, then we access the first capture group with this name, title, and we access the second capture group with this title, year. We print it out like that. Okay. Now, let's say we have the same thing, but with various different titles. So for example, something like that. As you can see, our pattern still matches, but it matches this and this and this. Actually, as you can see, this is the match, the first match. Oops, I removed that. This is the first match, second match, third match. Name of the movie and the year. Now we have different different movies over here, and each of them has two capture groups, the title and the year. And for that we can use the method captures iter. So we can do for caps in this regex pattern, captures iter, and we provide as argument the text we want to match upon. Then what we can do is print line and movie, and let me actually do it like that, and released like that. Then as arguments we pass caps, and again we use the same regex pattern, so we can again use the title, or we can again use these names or variables, if you will. Caps here. And now if I run that, as you can see, for each movie we have a separate line that prints out the name over here and the year it's released. That's because we have iterated over each capture group which matches the sequences of movies. I hope that's clear. So let me actually close terminal over here. Returns an iterator over all the non-overlapping capture groups matched in text. That's exactly the example we have looked at. So this will be the first, the second, and the third iteration. And on each iteration we can then access in the pattern the title and the year. Right? And what's also really useful, like that, we can split using regex patterns. We can use space or tab, one or more. Okay, then we have fields. This is a bag of string slices. We can then split. For example, we have here a, let's actually make this known variable so you can see it. Text. We have A, B, we have a tab with some spaces, C, D, and we have E, like that. So we want to split upon that, then we collect it inside the vector. Then we can print out the fields. That. Let's see how that looks. And as you can see, we have a vector, and these have been splitted upon these delimiters. So we split upon white space and tabs. And maybe just to show you again what I mean, what we've done over here. So we have this over here, and we are matching this. We are matching these. Okay, here tags are like that, but as you can see, if I do it like that, this is a tab and this is a space. So as you can see, this matches one or more white space or tabs. So we have split it upon these, and then we have collected it inside a vector. So this is how you clean up your data, because this could happen, you know, if you have user input, sometimes they have trailing commas or they accidentally press the tab, and so you can then clean that mess up. Okay, let's see. Now, of course, replace is very important. So let's see. First, let me show you the text. We have, for example, that, and we want now to replace anything that is not either a 0 or a 1. Okay? And one or more times, so we match anything that is not a 0 or a 1. As you can see, we have matched that. So I write that over here, 0, 1, one or more times. And as our input, we do like that. Now we can then call re replace, and we put the text, and then replace that with empty strings. So as you can see, what we've done here, we have matched anything that is not a 0 or a 1. So in this case, this has been matched, these three digits. And then what we have done, we replace in the text anything that matches this pattern with nothing. Okay? And this will be the output, 1 0 1 0. Now, another thing, using replace, we have already actually seen that, but let me actually show you once again. So, for example, over here we have this name. We want to match that. So how would we do that? First of all, let's do a group like that, and then we match anything that is not a comma or not a space. Okay, this matches anything that is not a comma and not a white space, and we want to match that one or more times, as you can see. Then we have a comma, so this matches that, and then we have white space, one or more, like that. So even if I do it like that, as you can see, it still matches. And then we again have, we can actually use it like that, one or more times, of course. Or in the documentation, it's like that. Anything that is not white space will get matched. But I think this is even better. And yeah, as you can see, again, we have two groups. The first one is Springsteen, and the second group is Bruce, which get matched. Okay, so I will copy that over here. Let us close the terminal. So we have this. We have an input of Springsteen rules. Now, what we can do over here, the replace, we can provide again this input, but we can then use our capture groups. Okay, so we can, for example, pass it here a closure captures. So this will capture these or this closure will take in these captures. We have two capture groups. One matches this and one matches this. Then what we can do is actually we return a formatted string like that, and we can access it like we did before, and then we print out result. And of course I have to import that, so captures like that, and this should be 1 like that. Let me see if that compiles. Now, as you can see, we have Springsteen Blues, and all we did is we have matched this and this. This will be the first group, this will be the second, and we have just replaced it to be formatted that the second one will be first, like here, and the first one will be the second, like that. Now again, over here you can just use named capture groups, which makes it a lot easier to work with. So we name this, for example, last, and this one we can name it first. So this is first and last name. We don't need this closure anymore, so let's see. We can then just format it like that, first, last, and yeah, let's see. Okay, I get a warning because I don't use this anymore. Let's do it again. As you can see, same thing, but with a little less syntax. And as we saw in the beginning, we actually just press it here, the X flag, and then we can even comment it like that. Last name first name. Same thing. And yeah, this makes it a lot easier. Okay. I think we have covered a lot, and I guess we are done with this course. I hope it was useful to you, and I'll see you in the next one. Have a good time.